Hey everyone, I'm Josh, and today I'm going to be going through the methods exam on November the 3rd, 2021, VCE Maths Methods. I did methods 2 years ago. I got a 50, raw 50 in that subject, as well as a perfect ATAR last year. And I just really enjoy maths. I enjoy doing maths, and today I'm going to be going through the paper. First time ever doing it, speed running it, hopefully. So yeah, I'm just going to insert it. Where is it? There we go. And today's hay fever has been really bad, like weather-wise, so excuse me if I need to blow my nose sometimes during the exam. Otherwise, I will hopefully do well. I will start my timer. Let's go. That's working. Yep, cool. Differentiate that. Okay. Differentiate dy dx is equal to -6e minus 3x. F dash for f dash of x is equal to, okay, that's the product rule. So derive the first times the second, derive the second. So derive the second. Yeah, I'm using a mouse as well, which is a little bit slow sometimes, so excuse me. Times the first, and then I just sub in 4, and then I get root 9 plus those two's cancel, so that's 1 over root 9 times 4. So that's 3 plus 4 over 3, which is 9 over 3 plus 13 over 3. Cool, that should be right. Find f of x. Okay, so this is an integral classic question. F of x integral x cubed plus x dx. That's equal to x to the 4 over 4 plus x squared over 2 plus c. Very important in indefinite integrals. F of 1 is equal to 1 over 4 plus 1 over 2 plus c is equal to 2. And so c is equal to 2 minus a quarter minus half. That's 1.5 minus 1.25. So that's 1.25. Actually, I enjoy fractions more. F over 5 over 4. So we need to write the whole thing. F of x is equal to x to the 4 over 4 plus x squared over 2 plus 5 over 4. That's okay. Yep. Oh, I'm just going to move my timer a little bit. There we go. Yeah, that looks okay. Where's my mouse gone? Cool. Range of g. G is a sine graph with amplitude 2. So the range of g is -2 to 2. State the period. That's 2 pi over 2, which is pi. Solve that. Okay, so sine 2x is equal to root 3 over 2. 2x is equal to... So sine 60 is equal to sine 60 is equal to root 3 over 2. Sine 30 is equal to half. So 2x is equal to 60 degrees, which is pi over 3. Remember, you need to add the p, not the period, just general. Or 2x is equal to 2 pi over 3. So it's the second quadrant. 2 pi over 3 plus 2 pi k. X is equal to pi over 6 plus pi k, or x is equal to pi over 3 plus pi k. And of course you have to write k is an integer as well. Okay, so yeah, there we go. That looks correct. Sketch a graph of... Okay, so that's a hyperbola with asymptotes x equals 2. Yeah, in real life I'd use a ruler, but I don't have that at my disposal. X is equal to 2. I'd also do this in pencil in real life. Y, the rest of the exam is by pen, because you don't want it not to read. There's a negative here, so that's a reflection in the x-axis. I mean, it doesn't really matter, but yeah, it looks like that. Should be an intercept around here, so if I sub in 0, that's -1 plus 1 plus 1. Yeah, so if I sub it, 0, 2? 0, 2, 1, yeah, 0, 2, no. So that's one of the arms. And the other asymptote here, if I sub in y equals 0, I get 0, so negative 1 on that side, not negatives cancel. So it's 2 is equal to x minus 2, so x is equal to 4. So 4, 0, yeah, and then, sorry for the wonkiness. There we go, 4, 0, 0, 2. Cool. Perfect. Find the values of x for which... Okay, so this is a graph of a hyperbola. It's the same graph, actually, so it's just everything above this point. So I find what this point is, and then between that and 2. So 1 minus 2 over x minus 2 is equal to 3. 2 over x minus 2 is equal to 2 over negative 1. So x is equal to 1. So x is equal to 1 is this point, so it's just from 1 to 2, not including 2, because the asymptote is 2. So everything, yeah, so that's all greater than 3. Cool. Two graphs here. The graphs have a common horizontal axis intercept. Okay, they're both parabolas. Find the coordinates of other horizontal axis intercept of the graph of G. Okay, so G, the turning point of G is 1. Actually, I should write this here. Vertex. Don't want to write. The vertex of G is 1, negative 4. If one of the axis intercepts is 2, 0, the other must be 0, 0, because they must be equidistant from this point here. So 1 would be the center of the parabola, 0 and 2 either side. So the other one is 0, 0. Transformations, yep. Okay, so I'm just going to do an image equation here. X dash is vertical axis, right? That's the y-axis. Yeah, you're getting your x value is getting smaller, so my image equation is going to be x dash equals half x. That's dilation from the y-axis plus 2 to the right. Okay, so I'll just rearrange that. Equals x. There's a 2 here. X dash minus 2. Yep. And then I sub that back into f of x. So h of x is equal to, I sub this into f of x, I get, is it f of x or f? Yeah, it's f of x. Okay, so I sub this back in, I get 2 x dash minus 2. Actually, I'm just going to lose the 2. X minus 2 squared minus 4. So then I get 4x minus 2 squared minus 4. And according to the horizontal axis intercept, so just make that equal to 0. H over x is equal to 0. Yeah, 0, 0, 4, 1. X minus 2 squared is equal to 1. Very important, if you have had a look at my other videos, x minus 2 is equal to plus or minus 1. So x is equal to 3, or it's equal to 1. So the two intercepts are 3 and 1. Cool. That looks right. 3, 0, 1, 0. Yeah, is that right? 2, 0, 0, 0. Yeah, no, that's right. Yeah, 3, 0, 1, 0. Yeah. Okay. Sorry, I was just confused because I was thinking about how if you have these two intercepts here, when you translate these, you don't get these two. But this is the graph of G and this is the graph of F, so they're completely different. Just like they're not even continuous on each other. So okay, sure. An online shopping site sells boxes of donuts. A box contains 20 donuts. There are only 4 types of donuts in the box. They are okay. It is known that and 20, there are only 4 types of donuts in the box. They are, okay, it is known that in the box, half of the donuts are with custard, okay? Half of the donuts are not, okay. A donut is chosen at random from box. Find the probability that it is not glazed with custard. Okay, I don't like these questions, but let's just do it. There are 20 donuts, so half of the donuts are with custard, so 10 are with custard. So these two will add to 10. 7 out of 10, so 14 are not glazed, 6 are glazed. So these two will add to 6. Oops, 6. These two will add to 14. 1/10 of the donuts are glazed with custard. So 2 out of the 20 are glazed with custard. So 2 are glazed with custard, which means that this is 4 because these add to 6, which also means that this is 8. And it also means that this is 6 because these add to 14 and that or add to 20. Find a product that's not glazed with custard, so that's 8 out of 20, which is 4 out of 10, which is 2 out of 5. Yep, there we go. The 20 donuts in the box are randomly allocated with 2 new boxes, box A and box B. Each new box contains 10. One of the 2 new boxes is chosen at random, and then a donut from that box is chosen from random. Let G be the number of glazed donuts in box A. Okay, sure. Find a probability in terms of G that the donut comes from box B, given that it is glazed. So probability that it's B, given that it's glazed. So that's the probability that it comes from B and it's glazed. So B and glazed over the probability that it's glazed. So what's the probability that it comes from B and it's glazed? Well, if you have G glazed donuts in A, that means you have, and there are a total of 6 glazed donuts, right? The total of 6 glazed donuts. That means you have 6 minus G glazed donuts in B. So the probability that it's B and it's glazed is 6 minus G times, so 6 minus G over 10 is the probability that you get a glazed donuts. When you have B, that's probably you get a glazed donut, but the probability that you choose box B is a half because you could choose box A and box B. So 6 minus G over 10 donuts, right? That sounds right, times a half, yeah? Over probability glazed. What's the probability that a donut is glazed? Donut comes from box G given that it is glazed. Probability that you pick a donut and it's glazed is here, right? 3 over 10. So probability that the donut is glazed is 3 over 10. I hope this is right. Times a half, so you get 6 minus G over 20, 60 times 10. That's equal to 6 minus G over 6, right? 20, 23, 10, 2, 6. Yeah, cool. That looks right. Yeah, that looks right. Cool. Okay, online shopping site has over 1 million visitors per day. It is known that half of these visitors are less than 25. Let P be the random variable representing the proportion of visitors who are less than 25 years old in a random. Okay, find probability P dash is greater than 0.8. Okay, so probability P dash is greater than 0.8. Okay, so 1 million visitors is just telling you that it's a large number, so you can't use actual fractions, you have to approximate it. Representative who are less than 25 years old in a random sample of 5 visitors. Okay, so if you have 5 visitors, then that's the same as probability x is larger than or equal to 4 in those 5 visitors. Let's say x is a binomial. Binomial? These visitors are less than 25. Yeah, no, sorry, I was trying to find the probability, but it's right there in front of me. It's half of these visitors. So they said not to use a binomial, so you have not to use a normal, so you have to use a binomial. So probability x is larger than or equal to 4 is probability x is equal to 4 plus probability x is equal to 5. So I don't entirely remember the binomial formula, but no, I kind of remember it. Yeah, 5 choose 4, that's just 5. Times, if you have 4 people who are less than 25, that's half to the 4. And if you have one person who's not over 25, under 25, that's 1. That's plus, probably, that's half to the power 5. I'm sorry, I'm going to have to sneeze. No, that's okay. Okay, okay, that was unsatisfying. Half, 6 times half to the power 5. Yeah, that looks right, I think. 1 over 1, 2, 3, 5, 32. Yeah, that's 3 over 16. Okay, hopefully that's right. The random variable has a probability density. Okay, show that k is equal to 2. Okay, so 1, 2, k over x squared. The x is equal to 1. So that's just, we can move the k up the front. 1 x to the power of negative 2, you raise it to, that's 1 negative, that should be right. X, this is, yep, 1 x to 2, yep. Okay, 1, 2 is equal to k, negative 1 over 2 minus 1 over 1 plus 1 is equal to k over 2. And that's equal to 1 because area under a graph is equal to 1, so k is equal to 2. Find e dash of x. Oh no, I might have forgotten this. E of x is equal to... No, it's, yeah, it's x. Yeah, no, it's this. X f of x, x1, 2. I tutored this, so I should know this better. X... Well, x times kx squared. Well, we can work this part out. This part is just x times 2 over x squared, which is 2 over x. Remember, you can cancel the x's as long as it's not 0, and it's not 0 because the domain. So that's just 2 over x. No, I shouldn't have 2 over x in here. I should have the antiderivative of 2 over x, which is 2 ln over x absolute value x. Yep. 2, 1 is equal to 2 ln 2 minus 2 ln 1. So 2 ln 1, e to the power of 0 is 1, which means that this is 0, so it's just 2 ln 2. There we go. Cool. The gradient of the function is given by that. The gradient graph of the function has a single stationary point at that. Find the rule of the function. Gradient of the function is given by that. For graph of the single... Okay, so... What? Do I just... Yeah, no. Isn't this... I swear there was a question that was similar before. If it has a stationary point at that, that means dy dx at x equals 3. How's my time going? Why is this... Sorry, give me a sec. There we go. X is equal to 3. That is equal to 0. So if I sub that in... do I even need to do that? Why is it giving me this information? Is there... Okay. I don't think... No, we don't even need this information. What am I doing? I'm just... Oops. I just need to antiderive this. X plus 6 antiderived x plus 6 to the power of 3 over 2 over 3 over 2. So that's 2, 3 minus 3 over 2. Not 3 over 2. Minus 2x minus x squared over 4. I'm sorry, it's been a long day. Minus 3 over 2x. So if I derive this from negative 3 over 2, 2x over 2. If I derive this, that's correct. Plus c, so 29 over 4. If I sub in 3, I get 2 over 3 times 9 to the power of half, that's 3, that's 27, minus 9 over 4, minus 9 over 2 plus c. So that's equal to, cancel that's 18, minus, oh no, I hate this. Why is it so messy? Please. 18 over 4, that's minus 27 over 4 plus c. Yes, then I move that to the other side. It's 56 over 4. 56 over 4 is 1, 2, 3, 4, 56. That's not a, yeah, it's 14. That's 14. So 14 is equal to 18 plus c. So c is equal to negative 4. So the final rule of the function is y is equal to 2x plus 6 over 3 over 2 over 3 minus x squared over 4 minus 3 over 2x minus 4. Okay, hopefully that's correct. Find the nature of the stationary point. Okay, so yeah, double derivative d squared y dx squared is equal to, derive that, you get x plus 6 x plus 6 minus a half. Yeah, so by subbing 3, that's 1 over 2 times 3. It's convenient. Minus a half, which is 9. 9, no, sorry, 3. 1 over 6 minus a half, which is 1 over 6 minus 3 over 6, which is minus a third, I believe. 1 over 6 minus 3, yeah, minus 2 over 6. So since it's negative, it's a local max. Okay, there we go. Consider the unit circle, 20 minutes in. Consider a unit circle that and the tangent to the circle at the point P shown in the diagram below. Okay, show that the equation of the line that passes through A and P is given by that. Okay, so we have this point here. And, okay, I'm so tired. This is exhausting. How do I work out that point? A couple of ways, I think. You could, do you have the gradient? How do you get the gradient? Oh no, this is, yeah. This is a triangle. Sorry, this is pi over 6. This is pi over 3 because it's a 60, 30, 90 triangle. So, because this length is 2, this is 1, this is root 3, which means that the, is there a better way to do this? Okay, stuff this. I'm just going to use this. Since we can draw another triangle here, this is 60 degrees. So 1 here, you have half is this. This is a half. And this is half 1 root 3 on 2. Yeah, this is fine, actually. So the gradient of this line is change in y over change in x. That's root. Actually, I'm just going to use the fact that this is pi over 6. So tan pi over 6, and then I'll make it negative. What's tan 30 degrees? That's sine 30 degrees over cosine 30 degrees. 1 over half times root 3. That's 1 over root 3. So this gradient is actually negative 1 over root 3. So you have that point. So you have y minus 0 is equal to negative 1 over root 3. x minus 2. Because this, I should write some working, because tan, okay, I might just cook the working a bit, but tan pi over 6 is equal to negative 1 over root 3, which is the angle of OAP. Okay, hopefully that's 2 marks. And then I'll just have to rearrange it. So therefore y is equal to minus 1 over root 3 x plus 2 over root 3. Forget what I did with that smaller triangle here. This larger triangle here, you can see that's to 1, 2, because the radius here is 1. So that's a 30, 60, 90 triangle. So this is pi over 6. So you can use that. This the identity theta is equal to tan inverse m to work out m. Cool. Let's r squared equals 1. Okay, where q? And let the graph of the function h be the transformation of the line. Okay. When let the graph of the function h be the transformation of the line that passes through a and p under t. Okay, so you have a transformation here. Let the graph of the function h be the transformation of the line. Okay. This is such a complex sentence. They could have made this so much simpler. Find the values of q for which the graph of h intersects with the unit circle at least once. Okay, so find the graph values of q. Where's q? Q. What is q? Oh, q is the dilation factor from the x-axis for which the graph of h intersects with the unit circle at least once. Is this transformation? This is the transformation of the line. So a dilation factor from the x-axis would make it closer or further away, which means that if it wants to intersect it with the unit circle at least once, then the line has to be between this point and between this point here. Sorry for the messiness, but what that means is that yeah, so between this point and this point. So q has to be this is just a perfect reflection. So q has to be between negative 1 and 1, not including 0, because it doesn't include 0. Is that it? Find the graphs of q for which the graph intersects with unit circle 1. So if it's negative 1, then it's a reflection in x-axis, so that's a perfect line here. If it's between negative 1 and 1, then it's, yeah, that looks right. Let the graph of h intersect the unit circle twice. Find the values of q for which the coordinates of the points of intersection have only positive. Find the values of q for which the coordinates of the points of intersection have only positive values. Coordinates of the points of intersection have only positive values. What? So it has to be in the first quadrant. Find the values of k for which the coordinates of the points of... Why is it 1 mark? I'm assuming you have to... Oh no, you just have to find... You just have to find between here. So why is this 1 mark? I mean, there's a line of working required. 0, 1, and 2, 0. The line that, since it's 1 mark, I have to write it down there. The coordinates of this line is, the equation of this line is y is equal to x plus 1. The gradient is a change in y of a change in x, which is, in this case, negative a half. Just subbing those into check, 2, 0. Yep, so it went from negative 1 over root 3 to negative a half, which means that the dilation factor is, oh, I hate this, negative 1 over root 3 over negative a half, which is 2 over root 3. I'm sorry, it should actually be root 3 over 2, I think, because it has to be less than 1. But since it's only 1 mark, I guess that doesn't matter. It has to be positive, which means that you can't include that point. Root 3 over 2 you can't include that, so it's root 3 over 2 comma 1, not including 1, right? Because 1 is exactly that line, which means that it only intersects it once, and if it's less than root 3 over 2, then if it's less than root 3 over, is this correct? 1, I'm just going to check that dilation factor from this to this is that dilation factor 1. Root 3 over 2, root 3 over 2, root 3 over 2, 7 root 3 over 2. Okay, I think that looks right. If it's wrong, then meh. For 0, Q1, let P dash be the point of intersection of the graph of H with the unit circle, where P dash is always the point of intersection that is closest to A. Okay. Yes. Okay, they've drawn it here, but if they want to be precise, sure. Where P dash is always the point of intersection that is closest to A. Let G be the function that gives the area of triangle OAP dash in terms of theta. Let G be the function. Sorry, I'm just multitasking right now. Just thinking through stuff. So thinking through other stuff that I have to get done this week. Let G be the function that gives the area of triangle OAP dash in terms of theta. Define the function G. What is G? Let G be the function that gives the area of oh, okay, sorry. This is just the... What is theta? Oh no, theta is given there. The area of this triangle is base times height over 2. What's the value of that height? Let G be the function that gives the area of OAP in terms of theta. Actually, it's not base times height over 2 because they're using theta here. How could you do this? Is there a formula for area? Do I have a formula sheet? Is there? I think there's a... Surely there's a formula. Okay. I'm going to check the formula sheet. There's definitely a formula. Which I could work out, but I don't want to. Should I work it out? I'll try work it out. Theta. Base times height over 2. That's let's just call this A. What is the formula? There's a formula here somewhere. Sine theta. I remembered sine theta something. Is it half BC sine theta? Let's see. Sine theta is equal to, if this is B and that's C, sine theta is equal to opposite over hypotenuse, opposite. Yeah, it is sine base. Okay, so I just kind of remember that, and just looking at this triangle, sine theta is opposite over hypotenuse divided by C times by C. That's opposite base. Okay, so this is a formula for triangle. So that's G of theta is half B sine theta. In this case, B is 2, half times 2, and C is 1 because that's the radius of the circle. So that's times sine theta. So that's just sine theta. Okay, that's simples. Okay, so now determine the maximum possible area of the triangle OAP dash. OAP dash. Okay, so if you have a line that goes like this, P dash is actually here. P dash is here. So anything in that direction means that the triangle is actually smaller, right? So if you decrease the gradient, the triangle is smaller. If you increase the gradient, sorry, this is all negative. So if you make it more negative, then you get to a point where it's tangential, and then after that point where it's tangential, I'm just going to get Control Z these now. After that point where it's tangential, you again, actually you don't get, yeah, you don't get contact. So everything in that direction means you get a smaller triangle, I think. So yeah, which means that the greatest area of this triangle should be when this is tangential, which is pi on 3, 60 degrees, right? Because we had our 30, 60, 90 triangle before. So pi on 3, I think. Is that just it? G pi over 3 is equal to sine pi over 3, which is equal to sine 60, which is root 3 over 2. I think that's it. 35 minutes. I think that's it. Because when your gradient gets larger and larger, you don't have contact. When it gets smaller and smaller, the P gets closer toward, P dash gets closer towards A. P dash is always the point that's closer to A. So we get smaller and smaller. Which, let me see, do you need a theta here or do you not? Do you need a domain here or do you not? I don't think it says you need a domain. Okay, that's all good then. Cool, so that was my attempt at the methods exam. Hopefully it's all correct, or it's mostly all correct. Please subscribe to my channel, and good luck with methods exam 2 tomorrow.